Okay, so we're recording now. Hi, everyone. So this meetup is, first of all, so just to start with the disclaimer, this is in no way financial advice. If you decide to stake Ether and gain rewards from the Ethereum network for running a validator, please do your own research. Today we need to look into the rewards and how they work in order to understand how proof of stake in general works on Ethereum, and how exactly the incentives work. And this is the reason we're going to talk about APR and things that are related to rewards. But this is in no way financial advice. Okay, so staking. First of all, in plain English, what staking is, at least in Ethereum context, you lock a given amount of funds, you run a node, and there you go, in time you gain rewards. I'll try to make the presentation in a show and tell manner, so I'll try to keep it as practical as possible, rather than having slides with lots of text and lots of theory. I'll try to make it as visual as possible. Actually, I've prepared it in a way that we would explore through different visualizations and dashboards, so that we would understand different aspects on how proof of stake works, what are validators, how node architecture works, and so on. Then in the end, I'll show you my own node that I run on Girly testnet at the moment, and I'll share a bit about my experience with that. Probably in a subsequent meetup, it would make sense to also take a look at the source code of different components in Ethereum nodes, but I don't think we'll manage for this one. So we'll take the general overview, but we'll also keep it as practical as possible. Good. So proof of stake. First, how it started. You have probably heard about the merge, the event that happened last year in September. So what was happening during that time? Basically, the entire Ethereum state, with all the transactions, accounts, smart contracts, and so on, passed to the proof of stake consensus. So Ethereum was entirely proof of work until September, and then the node runners have switched from proof of work consensus to the proof of stake consensus. And this proof of stake consensus was active for a while. So it was launched in December 2020. It was called Beacon Chain, and it was working as a parallel chain and consensus algorithm together with the old proof of work. Until 15th of September last year. And that's when basically Ethereum got rid of all the miners that were consuming energy and running GPU gigs in order to gain rewards for adding blocks to the chain. And Ethereum passed entirely to proof of stake. The transition was smooth, without any interruptions and so on. So basically, it was from one block to another. It's passed its entire state, like nothing happened, to proof of stake. Okay, and since we are going to talk about proof of stake, it makes sense to start from the staking, right? So from the activity of staking, and there are multiple ways to do staking on Ethereum. So first of all, you can do you can run your own node by yourself at home, and then you can take 32 ETH and deposit it and stake it on Ethereum. Of course, this has the advantage that you have direct access and full control of your node and your validator keys, but it has some disadvantages, meaning that you need to have some technical abilities, and you need to make sure that your node is up and running. Now, we'll see later that it's not that bad if you, let's say, I know your node goes down and you skip 1 or 2 days of blocks, of testing or proposing blocks, but it's still recommended to keep it at high availability as much as possible. Other options are staking as a service. So staking as a service is you have the 32 ETH, but you don't want to run your node at home. Then you would go to a staking service, and now they have different implementations and different rules. And you do not necessarily pass your 32 ETH or deposit your 32 ETH to them, but you give them away the validator keys. And what these validator keys are, basically they are used to sign different messages that you are going to post on the chain. For example, if you need to attest or propose blocks, your staking as a service provider would use your validator keys in order to do that for you. And there are some risks in there. For example, if you need to trust this service, otherwise they might mismanage your keys or the activity for a validator, and you might lose money and practically being penalized. Okay, another option is pooled staking. So this is very popular nowadays. Probably heard about Rocket Pool. You don't need the full amount of ETH. It depends on the exact implementation. You can, in some of them, you can stake whatever amount of ETH you want. In return, you would usually get another token that would currently, now it is called, so it has this name of LSD, which is liquid stake derivatives. And it would also be interesting to have a talk about this and study one of the protocols like Rocket Pool, for example. Then we have decentralized exchanges, which is basically the worst option that you could pick. So that means that you would give away your ETH to a centralized entity, but you don't know what happens behind. Maybe they are not even staking it for you. Maybe, I know, they are running a Ponzi scheme or something like that. Okay, so these are the basic ways you could do staking. But today, so no matter what you would choose at some point in time, it's still very recommended to understand how solo staking works, because this is the default native way of doing staking on Ethereum. So that's what we'll explore today, how you do solo staking.
I have a short question, if it's possible.
Go ahead.
So isn't a problem with the last three options because it's not a decentralized, they don't improve the decentralization?
Well, yes, of course. Also, so the disadvantages go kind of in that direction. So in staking as a service, it's not decentralized because you're giving away your validator keys. In pool staking, it's not necessarily centralized, but you have an intermediary. So you have a set of smart contracts and you have another network of operators that would have to run staking. So you still have to rely on something in between yourself and the Ethereum network. And then the centralized exchanges, of course, is the worst way of doing staking from this point of view.
Okay, thank you.
Good. So let's take a look. So I think this is one of the most important charts or diagrams that we'll take a look today. So this is the architecture of an Ethereum node. Before proof of work, we only had something that currently is called execution client. Before proof of stake, we only had something that is currently called execution client. The beacon chain, the one from this diagram, the beacon chain is implemented by something that's called consensus client. So that's what happened during the merge. So we now have the execution client, which is the part that executes all the smart contracts. And then and all the logic around that, it ditched the code that was doing or had something to do with mining. And now we also have the consensus client, which is the basically part of the consensus layer, and it's taking care of propagating blocks, validating blocks, and everything that is related to proof of stake consensus. Then we have validator client. I'll probably mute. Okay. Good. So then we have also the validator clients. And what's that? You need 32 ETH to run one validator. If you want to run 10 validators, you don't need a separate node. You just connect to your consensus client the 10 validators, and you deposit the 10 times 32 ETH. And there you go, suddenly you have 10 validators working on one single machine. Then how do you do that, or how you activate the validator? You generate the validator keys, which is basically a set of keys that do not have access to your funds, to your 32 ETH, but they are associated with the deposit that you do of 32 ETH. And then you import these validator keys into your validator client. And now your validator client can use your validator keys in order to propose blocks, do attestations, things like that. Okay, and another component that's interesting, we'll take a bit of a look later at this one. So it's Flashbolt's MEV. You probably heard about this one too. Okay, so this is the general architecture. We have the execution client or execution layer client, the consensus layer client, and the validator client. The execution client and the consensus client talk in between them through something that is called the exchange API. What it looks, or the usual flow that currently, how it looks currently in an Ethereum node. So let's say users would send a transaction. A user would send a transaction to an execution client. So that's the thing that you connect to, like port 8545 from MetaMask or whatever other wallet. So all the transactions get into the transaction pool on the execution client. And of course, it's propagated to other execution clients, because separately execution clients and consensus clients are syncing with their peers. Okay, then that transaction at some point will get packed into something that is called an execution payload. And that execution payload is, at some point, will become a block. The execution client will pass that execution payload or a set of transactions to the consensus client. And the consensus client will put them in a block, and all the additional data that is related to the block that it is going to propose, for example. And then it will use the validator client to sign that block and propagate it to other consensus clients. Now, other consensus clients receive this block. They take the block and re-execute them with their execution client. So just to make sure that the block is fine they're basically validating the block logically and re-executing all the transactions in the local state. And then the same block will be signed by the validator client, where the client will do an attestation. And that's what you'll hear this word often today. So an attestation means that I vote that something is okay from my point of view. I, meaning, let's say, a validator client, I vote that something is okay from my point of view, and it should better be in sync with everything that everyone votes for, because otherwise there is no other way to verify that something is okay to put on chain unless it has consensus. So even if it's something that is considered truth or false or lies, it doesn't matter. As long as it gets to consensus, it's considered to be valid. Okay, so this is the main flow that the transaction will take from being submitting to execution client to getting into a block and being accepted by the entire network. And for doing these operations, for proposing blocks and for attesting to blocks that were proposed by other validators and other nodes, the validators will get rewards in exchange. Now, another property of the exchange API is the fact that now you can have multiple implementations of both the execution client and the consensus client. And this is a thing that the Ethereum community is very is trying to promote heavily. So what the Ethereum community thinks is that if there is a critical bug in one of the implementations, and that implementation is too popular, let's say, or is used by the majority of the network, it can just crash the network. So you can get into a situation that just because of a bug, you have the entire network down. And that's why they started this movement that's called client diversity. And you have different implementations. For example, on execution client, you probably heard about Get. This is the most popular implementation of Ethereum protocol, and it's written in Golang. Then you have Nethermind, Aragon, Besu is written in Java. We'll take a bit look of this one later. This is written in .NET. Then you have the consensus clients, Lighthouse, Prism, Teku, and so on. So they are metric to say that the client diversity is okay is just to make sure that there is no usage that passes above 50% in popularity. For example, Get is 59% in popularity, or 60% almost. So this is considered a danger zone. They want to move you, or they are trying to encourage people to replace Get with some other implementation, in this case for execution client. And it's, in the same case, it goes to for the consensus clients. In this case, we have Lighthouse, which is the Rust implementation of the consensus clients. And it's somewhere between 33 and 15. Okay, so this is about the client diversity. I think it's a good way to prevent risk of and kind of strengthens the network. Good. Now about validators. So let's say you have decided to activate a validator. Yes, and activation is actually a phase that you have to pass through with the validator. You cannot just stake your ETH and there you go, you started validating the blocks on, or proposing blocks on the network. And there is a queue. So if you want to activate a validator, there is a queue that this dashboard is displaying some information about this queue. So current waiting time for activating the validators is 43 days. So this is the entry queue, and there is an exit queue. If you want to get out of the network and reclaim your ETH, you have to wait. In this case, for 2 hours. Actually, it's more than that, because there is a phase that you have to go through with your validator before you go into the exit queue. But anyway, you can see that people are rushing in to validate, and too few nodes or too few stakers are rushing out of the proof of stake. Okay, and then we have some charts in here. So validator queue and how it grew over time, queue wait time, so about 43 days. The number of active validators, we already have more than 600,000 validators. Then the supply stake. So 16% of the entire Ethereum supply is currently staked. And then we have the APR, which is, we'll see why it is dropping at the moment. It's inversely correlated to the number of validators being registered on the network. And now let's take a look. Yeah, so beacon chain, beaconchain.in. So what is this? This is kind of a blockchain explorer, very much like EtherScan is, but it only shows the information, or mostly shows the information that is related to the beacon chain or to the consensus layer clients. So let's take a look in here and what we have here. So first of all, the timeline in the beacon chain is divided in epochs. So each epoch, you have them here. So you'll see they are about how much? A few minutes apart, 7 to whatever amount of minutes apart. And if we go into an epoch, we'll see that every epoch contains 32 slots. Each slot, and this is the list of the slots, lasts for 12 seconds. And what is the slot? Actually, it is a placeholder where a proposer or a validator can assign a block to. and then the other validators will validate it. So we have the epoch, 32 slots within an epoch, and within each slot, we can have a block that is assigned or not. And if we'll take a look at, actually, let's take a look at the validator first. So here's the proposer of this of the block for that slot, and you can see various information that it had to deposit the ETH first, then it went into a pending state, and then it became active. And it has a balance which can go up or down, and depending if you get rewards or if you get penalties for the way you run your node. And then we'll have different information around here. The blocks that have been proposed, attestations, sync committees, deposit withdrawals, we'll take a look in more detail later, and some historical information about the activity of the node. And I'll also show my node on Girly later. Okay, but back to the timeline. So we have the epochs. So we have on this dashboard, we have 5 epochs and 32 slots in each epoch, and we have green means that a block has been proposed for the given slot. Then there are other colors like, I'm not sure exactly, orphaned. I didn't have time to look into the orphaned, but there's also, when you see a red square in this chart, it means that the slot is missed, meaning there was a proposer that was selected, but it did not manage to put a block into that slot. Good. Now, let me see what I wanted to show you here. I think we can go past to the next one. So let me pick the last epoch and the first slot, or actually the last slot of the last epoch. Yes, and I'll go back to the proposer or the validator that is has the role of the proposer, and you'll see that there are different entries in here. So basically, these are the rewards that the validator has received, and you see that there is a big difference between the rewards that here the validator received in here and in here, and we can take a look at the historical activity of this validator. So this is a pretty old one since July 2021. So a lot, so before the merge, people were receiving and earning rewards on proof of stake, even before Ethereum transition to proof of stake, just by running validators on the Beacon chain. Okay, but in order to understand the rewards, we'll need to dive a bit into a few slides that I have prepared. So when do you get rewards if you run a validator, if you have an active validator on Ethereum network? So first, most often you'll be selected for attestations. And as I said, attestations are basically votes that are consistent with majority of other votes that are submitted by other validators. Basically, you need to make attestations that are in consensus with others. Then you get rewards for proposing blocks, and these are the biggest rewards. And then you get rewards for participating in sync committees. And what is a sync committee? This is a random group of validators that is chosen from time to time to add supplementary information to the blockchain in order to allow light Ethereum clients to synchronize their state. So light Ethereum clients basically do not download the entire blockchain, but only the headers of the blocks. And this is considered to be a sync committee. Then you have the execution income. And the execution income is based on the fact that when as a user, when you send a transaction on Ethereum, you have the ability to say, okay, what's my base fee that I'm willing to spend, and what is the tip, or let's say priority fee that you want to pay for your transaction, so that your transaction will have a higher chance of being selected, and included into a block. And execution income means that priority fee, or the sum of all the priority fees that you include in a block as a block proposer. Okay, now how much? So this is a formula that's I hope it doesn't look too awful. So you have the base reward. Everything in proof of stake rewards on Ethereum are calculated based on this base reward, which is basically the average reward for a per validator per epoch. And the base reward is equal to the effective balance. So it depends on the effective balance. If you have 32 ETH stake, you'll get a base reward that is twice as low than if you have 64 ETH inner balance. Then you have the effective balance. That's then you have the base reward factor, which is a constant 64. Base reward per epoch is 4. Don't ask me why they didn't just simplify this and write 16 instead. I don't know. But the most important thing is the effective balance and the active balance. Active balance, or sum of active balance, is basically the entire amount that is staked on the network. And in order to not affect and to not allow this to be linear and influence the base reward and decrease the base reward linearly, they put the entire staked amount under a square root, and we'll take a look at that later. So the more Ether is staked on the network, the less the base reward is. This is the reason why we saw in that chart that the APR is decreasing as the nodes pile in into the network, but it's not decreasing linearly because they put a square root in there. Okay, and in more detail, as a validator, you have 5 duties and different weights that add up to a 64 by 64. So 14 by 64, if you attest to the source slot, and the source slot is basically the first slot in the previous epoch. Then if you write an attestation for the block in the first slot of the target epoch, it's not correct to say the first slot, but just to simplify things a bit, target, I would refer to them as being the first, because the rules are a bit more complicated in there. The target slot is the slot of the current epoch. Then if you attest for the head of the chain, then if you get selected and you do your operations that are required to for participants in the sync committee, then you get other reward if you propose a block or you have a proposal reward, and everything in here adds up to full base reward. Now there are additional rewards. I think that is called inclusion delay reward. So this is an additional reward that incentivizes these attesters or validators that send attestations to send attestation as fast as possible. And that's why they have this formula. So inclusion delay reward equals another base reward times 1 divided by the delay, where delay is the number of slots between the block proposal and the attestation that you have sent as a validator. So if I send my attestation as a validator 4 slots later than the block proposal, then I'll get a fourth of this inclusion delay reward. Then we have even more rewards for block proposers. So we have each block proposer will get 8 by 64 of base reward for each valid attestation sent by other validators that in the end, the block proposer includes into the block that they propose. And this is the main reason why block proposers get higher rewards. Then as a block proposer, you also can send evidence for misbehavior that someone did not do, some validator did not send attestations, for example, or more severe misbehaviors like slashing. And as a block proposer, you can get a part of the slash validator's effective balance or whatever. And that comes, and that's true for basically all the slashings that you detect for all the validators in block. Okay, and bit more. So this is about the proposals. So we have the 5 duties of the validator, the inclusion delay reward, and the special block proposer's reward. And then we have also the penalties and slashings. And people get afraid when it comes to here, to this part, because they think that I don't want to run a node because I might get slashed. But things are not that severe as they look. So there are 2 types of penalties. Some penalties that are more light, and then are slashings, which are more severe. So the actual penalties, or things that are called penalties, is if you miss to send attestations, either for the target slot or for the source slot. And the penalty equals to the amount that you would have been rewarded should you have successfully sent those attestations. So it's not that awful. So for example, if you know your node goes offline for 1 day, and then you fix it and you put it online, and it starts to send attestations again, you would regain these penalties during the following day. And then if you miss, as a validator, if you miss to send a head vote, you do not get penalized at all. And of course, if you inclusion delay is also not penalized if you just delay to the maximum. And then if you fail to, if you are selected as a proposer and you fail to propose a block, you will not get penalized either. Then slashings are more severe. You can, and there are various scenarios where you can be slashed, but you have to intentionally do something bad. You can either do multiple proposals or of blocks to the same slot, or send different, do double voting, or send multiple attestations for the same slot, or and the amounts that you can get slashed with rise up to 1 ether or so, and only in situations that are called inactivity leak, which means that during the same time other validators were also slashed, then this is a more severe situation where you get to lose even more of your balance. But again, you would have to do something really bad to get slashed. The only thing that is okay to remember, if you run validator, just make sure that you're not using the same validator keys on 2 different nodes, because the network would think that you want to get the reward twice for testing or for proposing blocks, and then that's a slashing scenario. Okay, then we have the execution rewards, which, as I said, are the priority fees of the all the transactions that have been sent in a block. So if you're a block proposer and you successfully propose the block, then you get the priority fees. And let's take a look. Some of them. So let's try again. Let's start again from the last slot, the last epoch. Okay, I'll take the proposer validator, and as you see, the execution income is a very large amount comparing to others. I'm not sure why the consensus income is so small for this one. Maybe it's better if I choose another slot. Let's take this slot. Poser. Okay, anyway, I'm not sure why. So probably because so each bar in here is the entire amount during one day. So it's 7th June, 8th June, 9th June, and so on. If we take a look at the rewards, it's basically the things that I showed you in the slides. So here. So we have attestation to the source, to the target, head vote, sync meeting, and proposal reward. So you can see attestation for the source, the target, and the head vote that has summed up to 12,000 GWAY. And here is a larger reward, which also includes all the attestation of the other validators that this proposer has included in the current block, and all the attestation of all the sync related activity done by other validators that the proposer has included was included in this block. Okay, questions so far related to rewards, penalties?
I just wanted to say that seeing what the reward was there in the chart, we can see that the execution reward won't be like putting the balance in the consensus in the actual staked balance, but it will be directly sent to the address that is staking, if I'm not mistaken.
Yeah, so you're saying that it will not get into this balance.
Exactly.
Okay. Yes, it might be that. I'm not sure, honestly. But okay,
as far as I know, that execution income is being sent.
Well, yes, you're probably right, Alex. It's for example, so this reward or this amount that is correlated to this high bar in here, high value in here, so it doesn't include anything that's related to the execution. Yeah. As a reminder, when you send a transaction, you specify the base fee in GWAY and then the max priority fee, and the base fee is burned, and the priority fee is received by the validator that has proposed that block. But yeah, I think you're right. I'm not sure exactly about the mechanism. Probably they just update the balance without doing the transfer directly in the state of the node. Yeah, other information that we could see in here are related to the blocks that this validator has proposed. The frequency of proposed blocks is not that high. I'm not sure if this validator wasn't active, probably. So it's a few months in between. So when you get to be selected for proposing blocks, then you should better have your validator up and running. Then we can see all the attestations. So there are lots of attestations in here that have been submitted by this validator. Then the sync committees. So this validator missed one, but the rewards for the participating in sync committees are not that high. Slashings, no slashings for this validator. We have deposits. So let's see, this validator has deposited 32 ETH 711 days ago on July 2nd, 2021. What else? And withdrawals. So withdrawals are the actual, I'm not sure exactly even withdrawals how work. If you do an actual transfer, or is this a timed operation that happens every 5 days or so, as I see here.
I have also 3 questions, if it's possible.
Yeah.
Okay, so the attestation, it's made one per node, or each validator can do attestation?
Yeah, so this is a bit of information that I've missed to add. So there is a process called RunDAO before each epoch, where a set of validators are selected, and at that time we know who are the attesters for the given epoch and for every slot of that epoch. So you can see here, this validator has been sending attestations every other epoch, and this goes up until, I don't know, this. So you get it to be chosen during an epoch, and then you can attest and send votes during each slot of that epoch.
That means, is it possible to be, for example, 2 validators to be chosen from the same node? Which I think is a problem, because then what is the advantage to have more validators on the same node? Because I think they are using the same execution client if they are all on the same node, and I see an issue here.
Well, let me explain. Well, I'll try to explain. So look, this is the actual number of Ethereum nodes that are currently running on the network. So there are about 8,000 nodes. I'm not sure if it's a very accurate number, because I've seen dashboards that show other figures in here, so 9,000 or 10,000 or something like that. But the idea is that there are roughly a bit less than 10,000 nodes on the Ethereum network. But validators, there are about 600,000, as we saw in this chart. So that means that there are nodes that are running multiple validators. And yes, initially I would have expected that you would have to run 1 validator per node, but I think that the problem, or why it is not possible to do that, is just because the communication of 600,000 nodes on the network would just be probably will not be sustainable, or probably the current implementation of the algorithm wouldn't handle it. Yeah, go ahead, Ovidiu.
Yeah, so I want just to add few things here. This is the schematic that we are showing. It's a Linux server hosting Ethereum node, Ethereum full node, and it's correct what this graphics says, but in reality, the validator client, which is connected to the full node or to the other nodes, it's a app running besides the Ethereum full node. So in this case, you can have multiple validators connected to the same node, but this doesn't mean that it's running on the same machine as the node itself. So basically, you can have 10 virtual machines connected to one node, and each validator can validate its part in the validation process. This is why you can have multiple validators and less nodes.
Yeah, and that's also true. So there is an API that the validator client is using to communicate to the consensus client, and although in the code base of the majority of the Beacon chain client or consensus clients, the validator code is actually in the same code base as the consensus client, you can run the process separately. And let me show also the node that I have set up, and it would be more clear. But yeah, thanks for mentioning this.
Okay, so I have just one more question, and then
Okay.
So why you say that the more Ethereum is staked, the reward is going to be lower? This is why is going like this?
Because of this formula. So this is the total amount. AB is active balance of one node, and sum of AB is the total staked active balance of all the nodes on the network. And it's inversely proportional to
I
the
understand the formula, but why they chose to go like this? I mean, because they doesn't support decentralization at some point with this type of reward, because you want to have more Ethereum staked, because you will have more validators and probably more nodes. And if you choose to go with rewards lower, this means you want and support to stop the decentralization.
Yes, that's true, but at the same time, they probably wanted to limit the inflation. Because if so, if each validator would have received the same base reward, no matter how many other validators are on the network, then you would get into a situation where you would just inflate the supply a lot. It's interesting to take a look at Vitalik's. Let me find it. So it's called it's written by Vitalik Buterin, and it's called Serenity Design Rationale. So Serenity was the previous name of the entire project of proof of stake, and here he explains a bit of why he thinks this is a good approach, and in the end, this has got implemented mostly in the final design. And you can see the formula here. So he uses a constant times the deposit size or the active balance of the current node divided by the sum of the total active balances. And he says that it's better than just it's better than just to use a square root in here, because otherwise you would lower the base reward even more. Anyway, it's interesting to take a look at this one. I'll drop a few links later in the meetup. Other questions?
I'm just thinking if maybe they in the future they will use the burn Ethereum to share as a reward, and this means you will have a constant Ethereum, like a constant total supply if you reuse the burn Ethereum.
Yeah, so you're saying that instead of burning Ethereum, give it to the validators.
No.
Okay, got it. It might. It needs to be any proposal like that needs to be analyzed from different perspectives, just to make sure that you don't miss and you don't end with something that is not in equilibrium and would probably not be working. But yeah, I was kind of surprised. I was expecting something a bit more complex, or at least more, let's say, more elegant, to put it in a way, than I have found. But it seems to work for now, so we'll see later. Okay, so I want to show another thing, and that's related to you probably heard about the MEV bots, right? Flash bots. Do you remember the scandal with the flash bots and the OFAC list and so on?
Yeah.
So what this does, instead of your consensus client just picking, or your execution client picking transactions from the transaction pool and packing them into a block based on the standard algorithm and propose the block, and probably not get as much of execution rewards as in an optimal way. They've created, so there are various entities that have created these MEV block builders, and you can connect your consensus client to a MEV block builder and require the MEV block builder to propose a block for you. And then that's how basically you can maximize your revenue from the execution income. And we have a graph, some data in here. So for example, at least this is what they claim. So this is an example of someone that's running with MEV and someone that's not running with MEV. And average total rewards per block. Yeah, so it's average total rewards per block without the MEV boosters and with them. So it's almost twice as high. And people start using these MEV block builders. And then, since these are run by centralized entities, that's where people from OFAC came, which is, this is basically the institution that says, okay, we are going to restrict access to the economic and apply economic and trade sanctions to different countries or individuals across the world. And this is where the censorship problem came, bubbled up, and it was a bit of a scandal and discussion on Twitter. So you can see on this dashboard how the percentage of blocks that were not OFAC compliant. And this is the reason it was such a big topic in the Ethereum community. So basically, these are blocks that have been censored from being produced, and these are the entities. So you can see different MEV block builders: Ether Capital, Celsius, Bitfinex, Binance, and so on. They're probably mostly running their own nodes, but being centralized, they are at the whim of legislators or let's say law enforcement. Okay, so that's about it. Now let me show you the node that I run. So this is my validator that I have set up on one node, and as you see, I keep losing money. This is the girly testnet, so this is not mainnet, and I didn't even have the 32 testnet ETH. I had to register to on a Discord channel, and I had to generate my validator keys with something that is called the withdrawal address, an address that is owned by this faucet, or let's call this funding bot. And then this funding bot has deposited the 32 ETH for me on Girly. And that's how I managed to run the node. Now let's see, why am I losing all the attestations? I'm basically missing all the attestations. I have activated the node in a week ago or so. I haven't been selected for running for proposing blocks yet, but I've missed all the attestations so far. Here's my deposit. No withdrawal so far, of course. And why does this happen? First, I tried to figure it out and debug it myself. I didn't manage to. I asked people on Discord, and they said that, okay, look, you're running on an old laptop. You do not have, you need an SSD drive, because the execution clients is always behind and is not in sync, and it's always falling behind with the chain. Let me show you how and why. So I'm tell me if I need to zoom this out, zoom this in. Okay, so what I did, I have connected, or this is the logs first. In fact, let me attach So this is the way you would attach you would operate with the node directly. So this is a JavaScript console, get, attach, and you attach to your execution client. And you can run various commands in here. Even sending transactions, the usual, even deploying contracts, calling contracts. So people were doing this from this console before. So if I do if syncing, I'll see that there is a current block and then there is a highest block, and there is a difference between them. And if I subtract them, the highest block minus the current block, it always fall behind. Round number 69. So it's always 60 plus blocks behind. And if I'm 2 epochs behind, that means that I lose the source attestation and the target epoch, or the target slot attestation. So this is the reason why my execution client is out of sync. Because an old hard drive. Initially, I thought that it's because of the bandwidth, but it's not. Okay, now, so this is the log of the get. I have chosen get as my execution client. So this is the log of the execution client. This is the log for the consensus client. And this is the log for the validator. And as Ovidio mentioned before, you usually run the validator as a separate process. I think in some implementations you can run the validator embedded in the same process as the main consensus client process. So what I see here is that this small warning message head is optimistic. It means that just my consensus, my execution client is not synced. Yeah, so this is my node on Gerli. If I would upgrade my hard drive, I would probably also get some rewards on Gerli. Okay, so that's about it, guys. One more thing I want to show you.
It's too slow.
Yes.
The SSD that you have now?
No, I don't have an SSD. I have an solid state drive. Actually, it's a hybrid SSD, but it's not the same speed, of course. It's not a normal hard drive or old hard drive. And I would need an SSD to catch up with the block production on the testnet or on the mainnet.
Okay.
Yeah. Now, the Ethereum Foundation is trying to encourage people to run their own nodes. There are various advantages to run your own node instead of connecting to Infura or Alchemy or other centralized providers, node services. So first of all, because of the privacy, so they cannot. So you connect to your own node. Your own node is connecting to other nodes on the network. You can choose the peers that you want to connect to, and then you don't have this middleman that can read your IP address and store information related to your activity on the chain. And there are also other techniques that you can employ to maximize your privacy if you run your own node. So this is the desired way to do this. And the Ethereum Foundation has released this program where if you apply, and I would encourage you to apply, and convince them that you have an interesting and creative way of running a node and convincing other people to run a node, then they would send you a dApp node home, or pay for your custom built node. And the dApp node If you choose to get the dApp node home, then basically they say they will send you this thing. I think it's this configuration. So this computer with 32 gigabytes of RAM and 4 terabytes of SSD. So I think this, or probably, I'm not sure if that, but this is Hopper, this is another, or Hopper, I don't know. So I would encourage you, if you want to run a node at home, just to go and apply this. And the deadline is 20th June. So there is almost a week to apply. I will add this to the meetup. Okay, I have submitted an application for the Ethereum developers community, and let's see, maybe we get a node. If not, it's fine even like that. Cool, that's about it, guys. Questions, other things to ask, comments?
So I believe that, if I remember correctly, you said that you didn't have to have those 32 Ether to the girl Ether to actually run your validator.
Yep, correct.
They came from another party, and basically it's like I don't know, you are in a pending state waiting for the actual Ether to be staked, and they come to stake that Ether, and then your validator is up, something like that.
No. You go to your dashboard. I don't have it prepared in here, but let me see. So you go to a dashboard. I'll try to grab it, or I'll try to find it. I don't have it at hand now. So what you do, you go to ETHStakers Discord channel. There is a Discord server, there is a channel in there, and basically that's the where you have to wait for it to get validated, so that people are just piling up to get girly ETH for free. But what you do in there is you do have to deposit a small amount. It's like a 0.01 ETH, girly ETH, but the deposit goes the same way as you would have deposited the 32 ETH yourself. But you have to specify the withdrawal address as being their address, or whatever the community's address. So this is the only thing. So I don't think you have to wait more just because you're using that bot, but you do have to wait through the activation period, and it can take some time. So you still get into the activation queue.
So basically, in this case, you're running a validator, but if you want to withdraw anything, you'd have to withdraw to their address.
Yes, exactly. You cannot withdraw. You can withdraw the rewards, but you cannot withdraw the 32 or no. I'm sorry. Actually, I don't know. Withdrawals should go to their rewards, their address too. I haven't made any withdrawal, but yeah.
I was wondering, given today's info, how the whole rocket pool science actually works behind the scenes, because it's those things in which basically you can run a validator, provide 8 Ether of your own, and the protocol would give you 24 Ether to stake, so you can fill up that requirement of 32 Ether stake.
Yeah, interesting. I haven't studied rocket pool. Are you guys interested into having a talk on that? I could also look into and probably prepare for, I know,
Yeah, maybe. I was
3
interested
weeks from now.
in this.
So in Rocket Pool.
Yeah.
Yeah. So Rocket Pool is an kind of a staking network for Ethereum. So it's an intermediary between you as a validator and, or let's say not, you don't have to run a validator, but there is a network of people that run validators for you, and you have to stake partially. And then there are different rules. I see Alex knows some information on that, but I will need to look deeper into that to understand how they designed it. But behind it, it's still the same staking, solo staking that we went through today.
The thing you said that I don't think is correct is that you said that you have your a part of, in our case there are rocket pools with 8 Ether that you offer to stake and 16, and you said that there are validators that take it
Any amount
from you, and then it's what I wanted to say is I don't believe there are other parties that are the validators. I believe that you can be the validator with only 8 Ether, but you get 24 other Ether from the protocol itself.
Okay,
to run that validator yourself.
Okay, then I withdraw my statement. So I was not sure. I probably was misled by this thing.
No, yeah. So basically, there are like two components in which there are the LSDs that, yeah, you stake with whatever amount of Ether you'd like, and you get the LSD that yeah, has the yield component to it. So but I believe that for what you stake, like the Ether you staked into the protocol, can be withdrawn to activate a validator if you come with 8 Ether or 16 Ether yourself.
So this is more for liquidity, and this is more like a thing that
yes, basically,
you are okay
basically
to the table. Yeah,
you can see it right there below, the two differences in what you get. If you have the LSD, you basically have a yield because you provided some Ether to the protocol, and obviously deserve some yield. But also, I believe that because of that, the validators will not actually give you the APR, the yield
whole
that
APR.
the entire API.
Okay, I understand. So if I don't want to run a node, I would put it here. I would get some yield, but it's not the entire yield that would cover. I know that would rise up to the current Ethereum network yield.
Exactly.
And because of that, the rest of the amount will be given to the people who actually run nodes, and that would mean that it's more efficient to run nodes on Rocket Pool rather than yourself at home.
Something like that.
Something like that. Okay, interesting. Okay, so let me take a look at this, and maybe I'll try to prepare something and just to understand. So there are a set of smart contracts in here, some other logic. Probably I know if there are some other components that are off chain involved. But yeah, it's interesting. Let me give me some time, or Alex, if you do want to research and do a presentation on Rocket Pool, then I'll leave this to you. It's especially if you're passionate about this.
Yeah, I'll think about it.
Okay.
And yes, so video, as far as I know, it's a non-custodial solution to run a validator with less Ether than you'd actually need to have if staking solo from.
Yeah. Okay. Okay, guys. Thanks a lot.
Thank
There
you for the presentation. Was a good one.
Thank you. So if there are no other questions, then we'll call this a day. And see you next time. I'll pause the recording, or I'll upload the video to YouTube, and I'll post it in the meetup. Okay, bye-bye. See you
Bye.
later.
Bye.
Bye.